The given diagram is of a mystic rose. There are 6 vertices and 15 different lines. Another mystic rose has 153 different lines. How many vertices does it have? So, if you can start thinking in the lines of, if you have 1 point, the number of lines is 0. If you have 2 points, you can make only 1 line, so straight line. If so, that's 1 line. If you have 3 points, you can make a triangle. There are no diagonals, so there will be 3 lines. And if you can continue, then you're likely to get a pattern, and that then you find what the nth term is going to be, and that will help you find how many vertices will a shape with 153 different lines have. So that's what I did. So if there is only 1 point, there are 0 lines, no lines are possible. If there are 2 points, you have 1 line. If there are 3 points, then there's 3 lines. That's the triangle, the 1 line, 2 lines, and 3 lines. If there are 4 points, then you see there are 6 lines. So that includes 1 from 1 point. From each point, you can draw 2 lines. So from this point, you can make 1, 2 lines. From this point, you can make 1 and 2 lines. And from this point, you can only make 1 line. That's this. And from this point, you can only make 1 line. So 2, 2, 4, 5, 6. So 6 lines possible if you have 4 points given. Next, if you have 5 points given, how many lines are possible? You will see there are 10 lines possible, counting the diagonals and the sides, of course. But if we do not double count, so you start from this point, you can have 1, you can have 2, you have 3, you have 4 possible lines. If you go for this point, you will have 1, 2, and 3 possible lines. And from here, you will have 1, 2 possible lines. From here, you have only 1 possible line. So it's 4 plus 3 is 7 plus 2 9 plus 1 is 10. So with 5 points you have 10 lines. Now then with 6 points you have 15 lines, and that is the diagram they have given us. So with 6 points, so you can count the diagonals and the sides. So if you have this as a starting point, so you have 1, 2, you have 3, you have 4, you have 5, so you can have 5 lines from this point. From the next point you can have 1, you have 2, you have 3 lines from the and 4 lines. 3 from this point you can have, the other lines are already drawn. You have 1, you can have 2, you have 3 points, 3 lines, sorry. From the next point, this point, you can have 1 and 2 lines possible. And from this point, only 1 line is possible. So you have 5 and 4, 9 and 3, 12, 13, 14, and 1, 15. So with 6 points, you can have 15 possible lines. So we can continue, and you see this is the pattern of triangular numbers, 1, 3, 6, 10, 15. It goes on. The numbers are a bit out of place, like with 1 point. If n equals 1, you get 0, like it's a little out of place. And then you see when you do 7, you get 21 lines are possible. So now we have to work out the sequence. So the way we do that is from kind of a tabular formation. So points 1, line 0. If points are 2, lines is 1. Points 3, line 3. 4, 6, 5, 10, 6, 15, 7, 21. So once we do that, then we find the difference, because the points is n here, and the lines are the sequence. This is the sequence. So you find the difference between the first term and the second term. So you get 1, and then again the next is 3 minus 1 2, 6 minus 3 3, 10 minus 6 4, 15 minus 10, 5, 21 minus 15 is 6. So it's a steadily increasing common difference, and you go to the next level, you get a common difference of 1. So because it goes into 2 levels, so definitely it's a quadratic sequence, n square, and it is the last difference is 1. So definitely there's a dividing by 2 involved, there's a half involved. So then what I do is I write down n square. That would give me 1, 4. So squaring these numbers, so that's 1, that's 4, that's 9, that's 16, 25, 36, 49. And the next step is to do n square minus n to check how far are we from the real sequence. So n square minus n, if you do 1 minus 1, so it's not the difference, sorry, just to do with the difference with the points in the n. So n square minus n gives you 0. 4 minus 2 should give you 2. 9 minus 3, 6. 16 minus 4 is 12. And 25 minus 5 is 20. 36 minus 6 is 30. 49 minus 7 is 42. And next is n square minus n. If we divide by 2, see, we get 0, because we get 0. And if we divide by 2, and then if you do 2 divided by 2, 1, and then 3, 6, 10, 15, and 21, and you see that it matches with our given sequence. So this matching, what this means is our sequence for the nth term is n square minus n divided by 2. So once we got that, it should be easy to work out the how many vertices does it have. So what we do is, now we have 153 lines, so the nth term should equate to 153. So n square minus n divided by 2 should be 153. So n square minus n is 306, and then we form a quadratic equation. N square minus n minus 306 is 0. We have to solve for n. So we solve for n using factorizing. So 306 is broken down into its factors. So you get 2 times 153, 3 times 51 is 153, and then 3 times 17 is 51. So what you see here is if you did 18 times 17, you would get 306. So we rewrite the quadratic term as n square minus 18n plus 17n minus 306 equals 0. And then again taking common terms, n times n minus 18 plus 17 times n minus 18 is 0. So n minus 18 times n minus n plus 17 is 0. And then what we get is, if n is greater than equal to 0, because n is greater than equal to 0, we cannot take n plus 17 equals 0, because n is, after all, the number of lines. It can't be 0, can't be less than 0. So then we get n is 18, and so the number of vertices it has is 18, and that's the answer.